All right, we are Algebra 2, Chapter 2, Section 1, 2-1, Relations and Functions. Relations and functions. So we're going to talk about domain and range. We're going to talk about what is a relation and what is a function. So first, let's talk about domain and range. So here, if I have a relation that's just a group of points, or set of points, -6, -1, -5, -9, -3, -7, -1, +7, and 6, -9. This is a relation. It's just a group or a set of points. And the domain are the x values. The domain, I'm just looking at the x values here, -6, -5, -3, -1, 6, oh, that's it, 1, 2, 3, 4, 5. Okay, that's it. So there's my domain. So my domain are the x values. My y values are the range. And so I just look at my y values that are part of this relation. I've got -1, -9, -7, 7, and -9. So I'm just looking at the y values and putting them in the range. The x values represent the domain. Now, let's look at another way you might see our x and y values are in a table that's sideways like this. So when x is 2, y is -2. When x is -1, y is -1. When x is 2, y is 0. When x is -1, y is +1. And when x is 2, y is 2. So this is another way to see a relation. The points are here, the x and y value of one point, x and y value of another point. So each of these represent a point. This top portion here, the x values, that's the domain, and the y values, that's the range. You can also think of the domain as the input and the range as the output. Now this particular relation, if I was to graph it, would look like this. I have 2, -2, -1, -1, -2, 0, and then -1, +1, and then 2, +2. So this would look like this. If I was to graph this as a function here. Well, it wouldn't be a function, but as if I was to graph this as a relation along this curve here. All right, so in this relation, I have a domain, which are the x values, 2, -1, -2, -1, 2, and my range is -2, -1, 0, 1, 2. So I just took my y values from here, put them in my range, my x values, put them in my domain. All right, let's talk about two different kinds of relations. So there is a discrete relation and there is a continuous relation. So a discrete relation, we're just going to draw them. This is a series of points. They might be in a row, they might not. But there might be points all over the place. But discrete means it is points and not a line or a smooth curve or something like that. Continuous relation, here's my coordinate plane. I might have a line that goes like this. That's a continuous relation, the line is. Or I might have a parabola, continuous relation. So what I graphed up here is a continuous relation. Now let's keep going. The next part that we want to look at is it a function? So I'm going to draw a coordinate plane. I'm going to draw a parabola like this. Boop, boop. Is this a function? So how do I know if this is a function or not? For every x value, there needs to be only one y value. So for every x, there is only one y. One y. And so if I look along here and I find all my x values, there's only one corresponding y for each x value. And so one way to check for that is if I do this horizontal line test, where if I hold a pencil or something like this, and as long as this curve or whatever this graph is, as long as that doesn't cross my pencil more than once, then it is a function. But when it does cross my pencil more than once, then it is not a function, because for an x value there will be multiple y values. For instance, let's look at this one back up here that I graphed. Notice how when x is -1, y is -1, and y is +1. So I've got two y values for only one x value. Same here with x is +2, y is 2, and y is -2. So there are two values here for y for the same one x value. If I put my pencil here, I can see this graph crosses my pencil 2 times. So this is not a function. Let's look at a couple examples here. So we're going to draw another coordinate plane. We're going to draw something like what we were just looking at. No, this is not a function. We didn't write yes over here, but yes, this is a function. No, this one is not a function, because right here at this x value or any other x value, I can see, boom, I've got a y value here that's +1. I've got a y value here, it's negative. I've got two different y values. This cannot be a function. This is multiple y values for an x value. So I've got one x value, it's got multiple y values. Any x value I choose here, if I choose like this x value, I've only got one y value. I can choose any x value on this, and I'm only going to get one y value. Now let's look at one more. Let's see what we think about this one. This curve starts down here at the bottom, goes over here, twists around like this, and then goes up like that. So is this a function? So if I were to do my horizontal line test, everything looks fine here. But right here, I've got 1, 2, 3 y values 1, 2, 3 for just one x value. So this one is, here's the problem area, even though everything else is fine. No, this is not a function, because I have multiple y values for one x value on this relation. All right, let's graph a relation. So let's graph y equals 1/2 x minus 3. Now, there are a few ways to graph this. One is you can plug in x values and get out what y values you're going to get. We make a t-table. We plug in some values for x. Let's just plug in 0. And then since I have 1/2 here, I'm going to pick values for x that are easy to take half of. So I'm going to say 2, 4, and 6. So when I plug 0 in here, 0 times 1/2 is 0. 0 minus 3 is -3. I plug 2 in. 1/2 of 2 is 1. 1 minus 3 is -2. When I plug 4 in, half of 4 is 2. 2 minus 3 is -1. And then when I plug 6 in, half of 6 is 3. And so 3 minus 3 is 0. So here's my x values, here's my corresponding y values. Now I can plug these in onto my graph. 1, 2, 3, 4, 5, 6. All right. And so when x is 0, so these are all points. 0, -3, 2, -2, and so on, 4, -1, and 6, 0. So 0, -3 is here. 2, -2 is here. 4, -1 is here, and then 6, 0 is here. And then here's my nice straight line. Make sure I put arrows on either side because it's a line. It goes on forever in both directions. There's my line. Now, you can do it this way, or you can use the graphing method that we learned a while back, where this 1/2 is my slope, means I'm going to go up 1 and to the right 2, or down 1 and to the left 2. And this is going to start at -3. So I go down -3, that's where I start, -3, 0. Then I go up 1 to the right 2, up 1 to the right 2, up to 1 to the right 2, and then I can draw my line. So either graphing method is fine for a line. Now, here's something that is new. Interval notation. So the domain and the range. We're going to talk about the domain and the range of this line. So the domain just means if I was going to look at this line, where are there x values that are included on this line? If I go forever to the right, there will be a corresponding x value on this line, and same way if I go forever to the left. So I'm going to say my domain is -infinity to +infinity. Now my range, if I can go, this line will go all the way down and it will go all the way up forever. So I'm going to say my range is my y values, is what I'm looking at. That's going to be -infinity to +infinity as well. And we'll keep doing this, and hopefully it'll kind of make sense as we go. All right, we're going to do a bit more work here. So let's do another example of graphing a function. So here is the function that we want to graph, y equals x squared plus 1. So hopefully you remember from algebra how to graph a parabola. But if not, let's do it real quick. Okay, so let's find the x value of the vertex is -b over 2a. Now, what does this mean? If I have y equals ax squared plus bx plus c. That's where those are coming from. And since I don't have a b value in here, then my b value is 0. And my a value would be 1. So negative 0 over 2 is just going to be 0. So my vertex is 0. That's my x value. Now I plug this 0 back into my original equation to get my y value. So 0 squared plus 1 is 1. So my vertex is 0, 1. 0, 1. And so my vertex is right there in the middle. And so what I'm going to do now is I am going to do a t-table. And my vertex is 0. And when I plug it 0 in, I got 1. And so now I'm going to pick 2 points on either side of this that I like. So I'm going to try negative 1 and negative 2. And I'm going to try 2 and positive 1 and positive 2. So I'm going to plug negative 1 in. Negative 1 squared is positive 1. Plus 1 is 2. Negative 2 squared is positive 4. Plus 1 is 5. 1 squared plus 1 is 2. 2 squared plus 1 is 5. All right, so let's plot these points. Negative 1, 2. Negative 2, 5. 1, 2, 3, 4, 5, way up here. Positive 1, 2, positive 2, 5. And here I have my parabola, nicely graphed. There it is. Now let's talk about the domain and the range of this parabola. So my domain are all the included x values. So this is going to go forever to the left, so all of these x values will be included on this graph. And it's going to go forever to the right, and so all of the positive x values are going to be included as well. So my domain is negative infinity to positive infinity. Or you might see it as all real numbers. My domain, or my range is different though. So if you can see here, my graph starts here at positive 1, and there's no y values, there's no representation below 1. So all of these are missing, they're not here. But it goes all the way up forever as far as the y values go. So my range is going to start at positive 1, and it's going to go to positive infinity. Now, here's a new thing that we need to learn, and that are these brackets. 1 is included here. So if it is included, then we do a hard bracket. If it's not included, then we do a soft bracket. Or if it's infinity, we do a soft bracket as well. Now another way to write this is y is greater than or equal to 1. Or you might see it as y values like this with a line, and then y is greater than or equal to 1. I prefer this method, so this is the one that we're going to look at like on the test and stuff generally, is the interval notation here. Okay, you try. So you're going to state, graph. Graph this and then state the domain and range. So I've got two things for you to graph. One is a line, y equals 2x minus 5, and the other is a parabola, y equals negative 2x squared plus 4x minus 1. All right, so follow the steps that we took to graph these things, and then we'll move on. You're going to pause here and then do your work, and then when you unpause, we'll do these together. Okay, go ahead and pause now. All right, welcome back. I am going to graph this line. And I'm going to find my y-intercept, which is negative 5. 1, 2, 3, 4, 5. When x is 0, if I plug 0 in for x, y is negative 5, so I know I have this point 0, negative 5. And so now I'm going to look at my slope here, which is 2 over 1. I'm going to go up 2 to the right 1. 1, 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and there's my line. I should draw it from the left to the right. There's my line. You could also do a t-table, and you can plug in some numbers, 0, 1, 2. When you plug in 0, you get negative 5. When you plug in 1, you get 2 minus 5, which is negative 3. You plug in 2, you get 4 minus 5, which is negative 1. So those are those points right here. 1, negative 3, 2, negative 1. Now my domain, my graph goes forever to the right and forever to the left. So my domain is negative infinity to positive infinity. My range, this graph goes forever negative and forever positive, forever down, forever up. So negative infinity to positive infinity. Now let's look at my parabola over here. So first off, I'm going to find the x value of my vertex. So my x value of the vertex is negative b over 2a. So negative b, so if b is 4, there's b and this is a. So I've got negative 4 over 2 times negative 2. So negative 4 over negative 4 equals positive 1. So I'm going to start my graph. So my vertex is, my x value is 1. So I know I'm going to have a line of symmetry right there at 1. And so if I plug 1 back in here, negative 2 times 1 is negative 2, plus 4 times 1. So negative 2 plus 4 is positive 2. 2 minus 1 is 1. So my vertex equals 1, 1. There's my vertex. Now I know that since the a value is negative, that my parabola is going to go down like this, but I don't know exactly what points are going to be there yet. So I'm going to plug in some points, x and y. I'm going to put my vertex right here, 1, 1, and now I'm going to plug in 0 and negative 1, and I'm going to plug in 2 and 3. When I plug in 0, I get 0 plus 0 is negative 1, minus 1 is negative 1. Plug in negative 1, I get negative 1 squared is positive 1, so that's negative 2, minus 4, which is negative 6, minus 1, which is negative 7. When I plug in 2, I've got 2 squared is 4, that gives me negative 8, minus 8 is 0, 0 minus 1 is negative 1. If I plug in 3, I can go through all that, I'll get negative 7. Okay, so let's graph these. So when x is 0, y is negative 1. When x is 2, y is negative 1. When x is negative 1, y is negative 7. 1, 2, 3, 4, 5, 6, 7. And when x is 3, y is negative 7. So there is my graph. Domain and range, and we'll be all set. For my domain, this goes forever to the left, and it goes from ever to the right. So my domain is negative infinity to positive infinity. My range, I have positive 1 is where my range stops. And so I always go from negative to positive when I'm talking about my domain or my range. So it goes forever negative. So it's going to go negative infinity to where it stops here, no more y values. It stops here at positive 1. And positive 1 is included, and so we get a hard bracket. And the last bit for this lesson is evaluating a function. So we're going to evaluate a function. So we're going to look at what function notation is. So function notation says if I have y equals 5x minus 1, for instance, we are now going to call this in function notation f of x equals 5x minus 1. We're replacing the y value with f of x. No big deal. Now, if I wanted to find out what happens when I plug in 6 for x, we'll say, I say f of negative 6 equals 5 times negative 6 minus 1. So if I were to put a t-table over here and I say I want to find out what y is when x is negative 6, then this is how I plug in negative 6. F of negative 6, and I just switch all of these x values for the x variables for the x value that I'm trying to find out what I'm going to get for my output if I input negative 6. What am I going to get for my y value? So f of negative 6 equals negative 30 minus 1, which is negative 31. So my y value when x is negative 6 is negative 31. Let's have you do one now. Let's have you do 2. I've got f of x equals 2x squared minus 8. I want to know, A, what is f of positive 6, and B, what is f of 2y. All right, just plug in the values and work it out, and go ahead and pause and get to work. Okay, welcome back. See how you did? So what I'm going to do is I'm going to plug in 6 for my x values. So f of 6 equals 2 times 6 squared minus 8. Now remember, parentheses and then exponents and then multiply and divide and add and subtract. So I'm doing this first. So 2 times 6 squared, which is 36, minus 8. 36 times 2 is 72, so 72 minus 8. F of x equals 72 minus 8, which is 64. Let's do this one now. This one's a little bit more tricky. F of 2y equals 2. All I'm doing is plugging the 2y in for x. Squared minus 8. And so now I just work this out. So I need to do my exponents first. So 2 times 2 squared, which is 4, y squared, which is y squared, minus 8. Now I can multiply this 2 in here. 2 times 4 is 8, y squared, minus 8. And that is my answer. F of 2y equals that. And that is it for lesson 2-1. Good luck on the homework.